Thank you. Okay, I think we are live. Good evening, everybody, from the Death Valley region of California. My name is Mike Jerry, and we have a beautiful December evening here in the desert, and hopefully going to show you some neat stuff tonight with the Cloudy Nights November Observers Challenge is what we're going to be doing this evening. And Roll's got some pretty cool targets again this month, so we're going to check that stuff out. So to get started, let me first turn off that thingy there, and then I can put up the image of my equipment, because this is how we start every night, or how I should start, so that you guys at least have a good picture of what I'm playing with here. And what I use is a 6-inch. Oh, hold on. Let me get that muted. Hold on. Okay. There. So now I don't have my own stream echoing back at me. Okay, so 6-inch f4 imaging Newtonian is what I use on a Celestron AltAz mount that's attached to a Celestron HD Wedge that stays polar aligned, and all of that is on my no expense spared cinder block pier that is all glued together with construction adhesive, and so it just stays outside permanently, and it comes with the storage compartments at no extra charge, which was kind of a nice thing. And up here in the focuser we have the camera stuck in, which tonight is the 533 MC, which is a color camera, and so that's what we are going to be playing with tonight. So let's dismiss this little thing here. Okay. So, let's see where I want to be. I want to be here, and then we want to look at the observing challenge. So, Roll has some pretty nice nice stuff for us tonight. We'll start off with some of the easy things, and we'll see how far we get before I get too cold or too hungry or whatever. But tonight we're going to start with IC 5146, which is the Cocoon Nebula. So let's go into our Stellarium, and I see 5146, boom, and it will zoom over there, yeah, pretty high in the sky, and we'll send the scope to it. And under the sequencer we need to put next target 533, so that it cranks the gain up for us so we can see what we're actually going to be looking at here. Okay, wow, I think that might be it. It's really faint. Let's see. Let's turn our ocular view on. Yeah, that looks like it's going to be it right there. A couple of little stars in it. And just a very faint fuzzy patch right there. So I think we're just going to start right here and do that as is. Okay, that's finished there. And we can get this out of the way. And we will see what comes up here in 60 seconds or so. Looks like it's going to be a pretty cool little... So this is the Cocoon Nebula. Mag 7 Nebula. That is... Well, it's in the northwestern sky, which right now has Cygnus setting pretty low, but it's just off the band of the Milky Way that you can see right here, between Cygnus and Lacerta here. See if we pick it up. Oh yeah, look at that. That's pretty darn sweet. Okay, let's adjust our histogram so that we get a little more contrast on this. And adjust our colors a little bit. Probably about right. Okay, and then we can zoom in on it a little bit here. Yeah. We'll see what comes in over the next several sub-exposures. Cocoon Nebula. Let's see what Wikipedia has about the Cocoon Nebula. Is there another? Yeah, it's Culwell 19. Yeah, Reflection Nebula in what is considered to be in Cygnus. That's interesting. Okay. And laptop wants some juice, so we'll do that. Okay, the Cocoon Nebula in the constellation Cygnus. The NGC description refers to as a cluster of 9.5 magnitude stars involved in a bright and dark nebula. Cluster is also known as Colander 470. It shines at a mag of plus 10. Well, we have it as 7.2, but apparently some of the catalogs are in disagreement over how bright it actually is. Its celestial coordinates are blah blah blah. It's about 4,000 light years away, and the central star that lights it formed about 100,000 years ago, so that's a pretty new star. The nebula is about 12 arc minutes across, which is equivalent to a span of about 15 light years. By viewing IC-146, the dark nebula Barnard 168 is an inseparable part of the experience, forming a dark lane that surrounds the cluster and projects westward, forming the appearance of a trail behind the cocoon. So here you have sort of a dark patch here, and then this trailing off. And so that's actually a dark nebula called Barnard 168. Let's see if we can't pick that contrast up a little now that we've got another couple sub-exposures in. That noise starts to clear up a little. Start to see some of the detail come in for that. Let's see here. Yeah, let's turn on a little background music. Actually, I forgot my water, so while this is going, I'm going to go get my water. Be back in a sec. Yeah, okay, that's better. Yeah, some pretty nice little details starting to come out in that. Lots of interesting little dark patches and lanes in it. I guess this is the central star they're talking about that's 100,000 years old, which in star age is very young. See if I can't increase that a little bit again. So it looks like you guys have shift click that to adjust it, and then we'll pick up be a little more aggressive. So it looks like it's a little bit dark as it's coming through the live stream. Thing I notice about doing these live streams is the algorithms that YouTube and others use to make it make the videos run more smoothly and operate a little bit better on lighter broadband connections. Is they compress some stuff out, so what ends up happening is you lose some of the signal, so I end up having to really kind of blow things out and make them look blown out on my screen to make them look good on yours. So it's good to monitor. But look at that dense star field. I mean, look at those stars. This is right in the band of the Milky Way. Over here. Yeah, see, so this is the band of the Milky Way going right through here. So we're kind of right in the thick of it. Kind of right in the thick of it. So there's just incredible star field. I mean, there's countless stars in there. So we're looking right along the arm of our Milky Way. The arm of the Milky Way that we are in. So pretty cool. Oh, we got a little bit of a satellite blazing through here. And when you back off, you can really see, in this huge band of stars, you can really see the dark nebula really pop out, where the dark region around the Cocoon Nebula really shows up with a tail that sticks off that way. Almost like a little amoeba or tadpole or something with an eye there. But just that dark nebula, the dark gases and dust and things that make up a dark nebula that's actually blocking out this very bright, dense star field of our arm of the Milky Way galaxy that we are nestled in. Cool, well there's 11 minutes. So, Cocoon Nebula, very nice. Alright, let's get on to the next item. Next target. And let's get over to... no, not you. You. Okay, M33. Oh, another big spectacular one. This is one of our neighbor galaxies. The Triangulum Galaxy. This will be a nice, big, bright, shiny object. This will be a nice, big, bright one. This usually just about perfectly fills the field of view of my camera, so it's usually a pretty fun one to look at. Yeah, actually looks like it's pretty well. Wait for it to settle. Yeah, it looks like it's actually pretty well centered, so I think I'm going to just try running it right as is. And we will see if if we miss any of it. I have to recenter, but it looks like it was pretty good. And it's an object that fits really well in my field of view of my camera at this focal length. So probably will be okay without having to mess with it too much. Probably get that out of the way. And I'm running 60-second exposures tonight, as always, at least on the DSOs, on those faint objects. Brighter things like star clusters and that, I will often reduce it. But for the dim stuff, the more distant stuff, yeah, there's our nice triangulum, looking pretty sweet. Nice big bright target to look at. Center this up a little bit better, like that. So this is one of our neighbor galaxies. It's one of the closest ones to it. It's one of our very close neighbors. Now, obviously, Andromeda is the closest one to us, at about 2.25 or 2.5 million light years away. This one is about a little under 3 million light years away, about 2.75, I think, million light years away. So it's one of our close neighbors, one of our sister galaxies to the Milky Way. She's a bright beauty. Okay, 2¾ million light years away. The third member is the third largest member of our local group of galaxies, behind Andromeda and us. It's one of the most distant permanent objects that can be viewed with the naked eye. Well, you'd have to be in a pretty darn dark sky environment to see this naked eye. Andromeda you can see with, you know, Bortle 3, Bortle 4-ish skies, but this one would have to be pretty darn dark. I don't know that I've been able to actually see this one naked eye from my yard, and my yard is somewhere in the Bortle 2 to 3. So, I'm actually a little surprised at that. The galaxy is the smallest spiral galaxy in the local group. Although the large and small Magellanic Clouds may have been spirals before they collided with the Milky Way and got stripped of their arms. But the Triangulum Galaxy is believed to be a satellite of the Andromeda Galaxy, or on its rebound into the latter due to their interactions. So it's kind of surrounding, it's kind of orbiting the Milky Way. I didn't realize that. Under exceptionally good viewing conditions with no light pollution, the Triangulum Galaxy can be seen with 20/20 vision naked eye. It really has to be perfect conditions. It's not as bright as Andromeda, which is quite a bit closer, and obviously not as big. So it is a little bit of a challenge to see it naked eye and would require some pretty ideal conditions. Observers range from finding the galaxy easily visible by direct vision in a truly dark and impliedly dry and cloud-free sky. In other words, perfect astronomy observing sky. Some people say they can see it with averted vision in suburban skies. Well, that's very surprising. It has a diameter of about 60,000 light years, which makes it about half the size of our Milky Way, and why it's the third largest. It's just slightly bigger than half the size of the Milky Way, and it may be gravitationally bound to the Andromeda Galaxy. Triangulum may be home to 40 billion stars, compared to 400 billion for the Milky Way and 1 trillion stars for Andromeda. That is a lot of stars. Estimates of the distance from Milky Way to Triangulum. Blah blah blah, middle of its range, making it slightly more distant than Andromeda. At least 3 techniques have been used to measure the distance. But it only has 40 billion stars. Pfft, only 40 billion. So it's 1/10 the number of stars as our own Milky Way, and of course Andromeda just kicks ass on both of them. So that's our big bruiser. But it certainly looks pretty in my camera, so probably get a little more out of that stretch without going too noisy. How is the color balance? It looks pretty tight. Okay. But it's a big, pretty thing, there's no doubt. I could zoom in a little, but I'd lose some of it if I did, so I don't want to zoom in too much. Too bad if it was the other orientation, I could zoom in quite a bit more, but oh well. Not now. Still, you can see some really nice spiral arms, different puffy areas, which are probably high energy areas of star formation that are going on throughout the galaxy. Of course, all these individual stars we see here are very much in the foreground. Those are in our galaxy. In fact, anytime you can see a star in the sky, it's always in our galaxy. So when you see pictures of more distant objects, other galaxies, any individual star you see is always in our galaxy. Anytime you look at a nebula or star cluster or anything, those objects are in our galaxy. So all these little stars here are definitely in the Milky Way, but these puffy little regions here are all high energy region in the other galaxy. And they're all probably star formation regions and all that kind of thing. So alright, time for me to take a drink. Alright, coming up on 10 minutes on what will probably be the biggest and most spectacular object we're going to do tonight, but as we get deeper into this, it'll become more and more challenging. But there's 10 minutes on Triangulum. Beautiful object. Great object to image. Okay. Let's see what's next. Alright, M76. M76. Oh, and okay. Now a little planetary. Yes, this will be much smaller. But in a way, brighter. So, the little dumbbell. Okay, yep, there he is right there. Okay. Let's see. This may be so bright that 60 seconds might be too much. In fact, I think what I might do is turn the exposure down to 30 seconds. Clear this back out. Because planetary nebulas are very bright little suckers. So we'll see what happens at 30 seconds. Okay, now I've got my hat on, and I'm Much warmer. Okay, so obviously going from a 30-second to from a 60-second exposure to a 30, we got to make some histogram adjustments because the light levels are way different. But you can certainly see it in here. You can see why it's called a dumbbell. It's or apple core shape. And it's got some nice rings around it here too, which is all part of the bubble that a planetary nebula creates. And see, with even the 30-second exposures, it's still all pretty blown out. But I'm thinking that might be good enough, especially if I back off a little bit on this. Planetary nebulae are very bright objects. They're small, bright objects. So, but they have a lot of contrast range in them too. The cores are usually pretty bright, and then you get the outside parts that are pretty dim. And planetary nebulas are basically the death process of a star, much like our own. Our own sun may someday go through this process. The star burns out of one part of its fuel, burns out of the hydrogen that a regular normal sequence star burns, and then when it runs out of that fuel, it starts burning a different fuel. I believe helium? I don't know. Anyway, whatever it is, it burns a different fuel and burns hotter and expands. And when it expands like that, it blows off its outer core. Its outer layers expand out away from it. And in fact, in a few billion years, our own sun will expand, possibly even to the size of the orbit of the Earth. So it's going to grow quite a bit. And it blows off those outer layers. But it just blows off the outer layers. The inner layers are still there burning, and so as those layers expand out into space, the central star that's still there, which will eventually turn into a brown dwarf, continues to illuminate it as it flows out into space. So that's what we see here, is a central star, which might be able to make out right there. That might be it. It continues to burn and illuminate all of its own outer gases that it's blown out into the surrounding space. So they're kind of neat objects. Good here, we are. Very good, very good. I can probably get a little more aggressive on that stretch now that we've got some sub-exposures in to brighten it up a little for you guys. You can see it a little bit better. Or at least you'll see the outer wispy parts a little bit better. It blows out the inner core more, so that now we can't really see the central star. They are challenging objects because there's such a mixture of contrast. Let's see what Wikipedia has to say about M76. Okay. Yes, what you have to specify is Messier 76. The Little Dumbbell Nebula, also known as the Barbell or the Cork Nebula, is a planetary nebula in Perseus, discovered by Pierre Marchand in 1780, and included in Charles Messier's catalogues of comet-like objects, but things that weren't comets, as number 76. It was first recognized as a planetary nebula in 1918 by the astronomer Aber Daust Curtis. However, there is some contention to this claim, as Isaac Roberts in 1891 did suggest that M76 might be similar to the Ring Nebula, being instead as seen from the side view. So he was the first one to speculate that it possibly was a planetary, just like the the Ring Nebula. The structure is now classed as a bipolar planetary nebula, denoting two stars which have burst, leaving neutron star or white dwarf remnants and luminous envelopes. A bipolar planetary. Two stars have burst, not just one, but two. Distance to M76 is about 2,500 light years, making it about 1 1/4 light years across. Well, that's interesting. It's not one star that has gone through the end of process, it's actually two orbiting each other, and so their gravitational fields have made the interesting barbell shape. Huh. That's kind of cool. The total nebula shines at apparent magnitude of 10 with its central star or planetary nucleus. Well, according to what they're saying, it has more than a central star. It has two. The Little Dumbbell derives its common name from the resemblance to the Dumbbell Nebula, M27. It was originally thought to consist of two separate emission nebulae, so it bears the NGC numbers 650 and 651. Interesting. Well, that's interesting. Two different stars. Huh. Pretty cool. That's interesting because the regular dumbbell nebula, M27, has almost the same shape. It doesn't have the rings out at the edge like that, so at least not quite so strong. But it definitely has that apple core or dumbbell shape, but it's only one star. So it's interesting they think this is two stars. It's interesting they think it's two stars. So now if we turn the stretch down again, let me move this a little bit there, but if we turn this stretch down again, you can see a little bit of the central. You can see there, right? Well, maybe there's two stars in there, but that looks like a central star to me. But maybe the two stars are orbiting each other so closely that we really can't separate them. They're too small and too faint that we actually can't really separate them anyway. And there could even be stars that are in the background. Since this is only 2,500 light years away, we could be seeing a few stars back there that are even further away than that. So some of them might actually be showing through. And then again, there could be some faint stars that are in the foreground, so kind of hard to tell with an object this close. Kind of hard to tell. Of course, then when we zoom in this far, I'm seeing the individual pixels of the camera, so. But interesting. And of course, when we crank up the stretch again, the outer parts show really well, but then it blows out most of the inner part. You can still see this star here. This one's probably a foreground star. Its color looks pretty clear, so. But hard to tell with some of these here. These could be background stars. You know, they could be backgrounders. Pretty neat looking little thing though. The Little Dumbbell Nebula. There, seen in its full context. Not a very big object, those planetaries, but they're typically bright and interesting. Okay, no, I need to go here. Okay. NGC 891. Okay, NGC 891. The Silver Sliver Galaxy. Okay. So this will be a galaxy, which is not ideal with the color camera, but it's a Mag 10, so it should still look pretty nice. Yeah, you can just make it out there. Okay. This one will definitely do with a full 60 seconds. Yeah, should look nice in our sensor. And what is this? NGC 891. Let's see what Wikipedia has to say about this. NGC 891. Edge-on unbarred spiral, about 30 million light years away, so about 10 times farther away than the Andromeda Galaxy. So, quite a bit smaller, but it's a pretty spectacular one. Woo, yes, and again, going from 30 seconds to 60 seconds makes a big difference. Yeah, there we are. Yeah, and I'm starting to see see how we're seeing gaps here in the gaps. The telescope is a little bit inverted upside down, so as a result, we have some focuser flop on there. Is there a bright enough star in this area that I can... Yeah, I can probably focus on this one. So let's... Next target. I'm going to try refocusing, because this really is a spectacular little galaxy to see. So I'm going to check the focus here really quick, adjust it really quick, and then we'll go right back to that galaxy. Okay. That should have our focus much better. Much better sharpness for this little galaxy. Okay. Let's try this again. Because the dust lane, well, we're seeing this galaxy right edge on. So the dust lane cuts right through the middle of the central bulge. So it really is a nice one to get nice and sharp. A nice one to get sharp. So it is 30 million light years away. It's in our local supercluster. The object is visible in small to moderate-sized telescopes as a faint, elongated smear of light, with the dust lane visible in larger telescopes. Which is why I love going to a camera, because it turns your small telescope into a very big one. Yeah, there we go. Now we're getting some nice sharp stars back there, and you can already see, just even on the first sub, that nice dust lane that bisects the central bulge of the galaxy itself. So this will come in nice now as we continue to pull in some sub-exposures. In 2005, due to its attractiveness and scientific interest, it was selected to be the first light image of the Large Binocular Telescope. In 2012, it was again used as the first light image of the Lowell Discovery Telescope with the Large Monolithic Imager. Alright. What else does it have to say here? Looks as the Milky Way would look like when viewed edge on. Some astronomers have even noted how similar NGC 891 to NGC 891 our galaxy looks as seen from the southern hemisphere. And in fact, both galaxies are considered very similar in terms of luminosity and size. Studies of the dynamics of its molecular hydrogen have also proven the likely presence of a central bar. Despite this, recent higher resolution images of its dusty disk show unusual filamentary patterns. These patterns are extending into the halo of the galaxy away from its galactic disk. Scientists presume that supernova explosions caused this interstellar dust to be thrown out of the galactic disk toward the halo. Cool. Alright, let's there, stretch it a little more so you guys can see it a little better, but it is a beautiful target. It is absolutely a beautiful target. I guess it was a little bit off. What else? something I forgot to do, too. I forgot to turn on these filters, which help a lot in making things sharper. I should have done that earlier. A great object. You can also see it has sort of a halo look to it, not really sharp. It has kind of almost a glowy look to it. And what they think that is a cocoon of stars that's kind of surrounding it, that's perhaps the remnants of another galaxy that has collided with it, and that it's in the process of tearing apart and absorbing. But yeah, because usually they're a bit sharper on the edges, at least spiral galaxies. This one just almost has kind of a glow to it. But definitely a cool thing. That's nice and bright, and you back off from this a little bit, and you see more of the dark dust lane going through it. Sweet. Okay. Silver Sliver Galaxy. What's next? 7331. NGC 7331. Boom. Okay, oh, this is the Deer Lick group, so this is going to be a cluster of galaxies. Okay, let's go back out to catch our whole view here. Now, because I'm re-inverting the scope in a different part of the sky, the focus may be off again, so we'll have to see how this comes out. Yeah, they're a little smudgy. Let's pull a sub and see how it looks. I think we might have to refocus, but we'll give it a shot and see what happens. Well, thank you, Michael. I'm not sure I'm that much of a pro. Been doing it for a little while. But yeah, no one's paid me yet, so not actually a pro. Actually, I was looking back today in the announcements thread on Cloudy Nights, where I know you're a member, and I did my first live stream on October 11th of last year. So, been about 14 months for me that I've been doing this. So I've done a few. It's been interesting. It's a fun process. I mean, I really like sharing it. You know, I really like sharing this stuff. You know, and with the skies I have, I'm spoiled. So it's a nice thing to be able to share, because even when you don't have a bunch of clouds on the East Coast, it's still hard to beat Bortle 2 to 3 skies and that nice dry desert air. So it's a good thing to share, and so I love doing it. Of course, the one downside with living out in the middle of the desert is that you know, you're typically limited by your internet bandwidth, so that can be a little bit of a challenge. But out here we actually have pretty decent internet. It's microwave based, microwave transmitted out here. It's not satellite, and they're certainly not going to string a cable out here, but it's microwave transmitted by a company out here called LV.net, and actually works, considering where I live, it works really, really well, so I'm kind of happy. And yeah, the sequencer is a pretty cool thing. And now Robin has made it with a nice wizard that you can use. So if you don't want to actually get in there and hack stuff, you can. But it's all high level stuff. You know, you're not writing code. You're just pulling blocks of things out and adjusting the parameters. So this is a sequence that I use here, which goes back to the imaging. Once I've found the object, this puts everything back to goes to the image. So it sets the gain to 300, exposure to 60 seconds, resets the display histogram to be reset position, so normal, starts the live stacking, waits for 2 seconds, and then resets, which clears the old image from before. So, you know, you can just take blocks of things out of here, drag them into your script anywhere you want, and set the parameters. So it's actually pretty easy to use, and there's lots of threads on it in the SharpCap forum. At least last time I was there. But but it's yeah, it's a pretty cool thing. It saves me a lot of clicking, because when you are searching for objects or going to your next object versus starting your stack, starting to image an object, it's all the same clicks every time, several clicks every time, same thing, going to and from every time. And so the sequencer just makes any of those repetitive kind of tasks that you do with imaging really nice. So here is the Deer Lick group. So you can see there's just a nice little cluster of stars. Again, the color camera is not ideal for this, and we are slightly out of focus, so I am going to have to readjust the focus. But you can see in here, we've got the bigger galaxy here, and then 1, 2, 3, 4, 5. There's a bunch of galaxies in here. And this is called the Deer Lick group. Oh, you live in the boonies and use a cellular modem and router. Okay, yeah, cell. I have to boost my cell signal first. Yeah. Yeah, I'm not sure. Well, yeah, you have to boost your cell signal because, of course, whenever you're doing wireless, your bandwidth is directly proportional to your signal strength. So the bigger, the more bars you get, the more you can transmit. I'm able out here to transmit in 720p, which is, considering where I live out here in the middle of the desert, that's pretty amazing. And there are nights when it's spotty, it's herky-jerky, and sometimes the video comes out as stop and go, but most of the time it works pretty darn well. Alright, let's get this put back where I want it. Shift click this to adjust it slowly. And we'll bring the stretch in a little more aggressively. Give you guys a little more brightness on there. But yeah, this is a small cluster of galaxies. Maybe my next my next session I'll use the mono camera. We'll do more galaxy type things. But it's doing okay here. I think I am a little bit out of focus. Again, you can see that I have double diffraction spikes. So, but not too bad. Yeah, I remember when I first started. SharpCap itself is this wonderful piece of software. It was a bit daunting. It's like any powerful piece of software. There's a learning curve to it. There's a lot of moving parts, and especially with EAA, where you're combining all these different pieces of equipment: telescopes, mounts, cameras, computers, all this stuff. There's a lot of moving parts. You're spinning a lot of plates while you're doing these events, and adding the live stream too. It throws in a few more parts, because now you got to be connected to YouTube, and you've got to use something to actually send the signal, which in this case I'm using Open Broadcaster Studio, which is an open source broadcasting suite of software, which works really well. Yeah, it takes some getting used to. There's a lot of plates, but eventually you get your procedure and protocol down, which works for you, and it gets fun. I mean, it was fun from the get-go, but yeah, there's a lot. You're spinning a lot of plates, so there's just a lot to deal with, a lot to keep track of. But I enjoy doing it. I've enjoyed my astronomy for many years, and the EAA came along. The use of camera came along, and then the electronically assisted astronomy came along, and that really just finally made it so that I was able to see the things I wanted to see the way I wanted to see them. Throughout my life, from when my parents first got me my first telescope, my first little rickety Sears refractor, I was hooked. It was, it wasn't the greatest scope, but boy, it was what I needed to get started, and it was just amazing. I was amazed by what I could see. And throughout the years, I've had various different scopes, Dobbs and larger telescopes, but faint gray fuzzies are still faint gray fuzzies, no matter almost how big a telescope you get. If you get really big, more than 2-foot mirrors and whatnot, then you can start to see a little color in them. But it wasn't until the advent of cameras, the electronic cameras came along, that really opened things up and allowed us to see things that really only professional astronomers working on telescopes that are measured in feet of diameter could see before. And so this is, and obviously it made it so that now it's on the computer and could now be broadcast. So it's a wonderful marriage of technologies, and I've really enjoyed doing it. So Michael, yes, I am using a coma corrector. I'm using a Beta MPCC on this, which isn't the most heavy duty of coma correctors, but it works fine enough at f4. If I was going faster than that, I'd probably need a better one, but for f4 it works pretty well. I mean, I get pretty good stars right to the corners, a little tiny bit of pin cushioning out there, but not too bad, so it works well for me. The Edmund Astroscan. I never had one of those, but they look like neat little things, and something that's great for a younger person to be using to start off with. Get you used to that Dobsonian concept right out of the gate. And And obviously, since you can see my diffraction spikes, you know that I am using a newt, not a refractor, so I like those. Okay, so there is the Dirichlet group. So let's move on to the next thing. What is next, roll? Okay, so 7635 is next. NGC 7635. Boink. Oh, the bubble. Here's a great little target for a color camera. Again, mag 10, although a faint. It's pretty faint. It's a pretty faint one. Yeah, this is going to be it right up here. And again, we're upside down, which is, I'm glad I didn't change the focus. Yeah, so we're going to be, yeah, right up there. And M52 is right there. Where's 52? Let me see if I can't pull this in a little bit better and maybe get M52 in the view as well. Yeah, there's 52 coming in very top. Not sure I'll be able to get it really well, but we'll get a little taste of it. I don't want to take the bubble nebula too far off the center, because I want to obviously be focused on it. But alright, so let's let that still drifting a little. One thing about this evolution mount is it does have some backlash, and no matter what I've tried to do, I can't seem to make it stop. I can't seem to adjust it out, no matter what. I've even pulled the thing apart. I just can't seem to make, no, not that. Just can't seem to make it quit with its backlash. Oh, you use an MPCC as well? Yeah, it's a simple coma corrector, simple, inexpensive. What I really like about it, other than the fact that it's simple and easy to use, is the fact that it doesn't change your focal ratio. It doesn't slow your scope down. Most of the coma correctors I know of will slow your f4 scope down to f4.1 or 4.2 or something, and they actually have a deleterious effect on the speed of your scope. And so that's what I really like about the MPCC, is it does not slow your scope down. Your f4 imaging newt stays f4, which I think is pretty cool. So let's see how we're doing on the bubble here. Yeah, that works. M52 up there, all glowing. It'll be completely blown out, of course, because we're doing a 60-second exposure, which will be nice for the faint things, but not so much for the big bright star cluster up there. And we'll back this off a little bit initially. Come on. Back this off a little bit initially so that we're not getting too noisy on the first. But you can see the nice arc of the bubble right here. It's in the nebula. So there's a bubble that's right here in the nebula. And I'm actually going to run in and take a quick bathroom break. So while this is coming in, I'll go do that. So I'll be right back. Okay, boy, bathroom breaks take a lot longer in the winter than they do in the summer. So many layers to fight through. Okay, how's our bubble coming along here? Looks like it's coming along pretty nice. Yeah. Tweak this a tiny bit. And stretch a little bit more. Make sure our color balance, our color balance is off. There we go. That's a little better. The Bubble Nebula. Let's see what Wikipedia has to say about the Bubble Nebula. Bubble Nebula. Mm-hmm. 635. Bubble Nebula in Barnard's Galaxy. Yeah, there's more than one. Okay. It's a hydrogen beta region, emission nebula in the constellation Cassiopeia. It lies close in the direction of the open cluster M52, which we can see in the upper left of our view there. The bubble is created by the stellar wind from a massive, hot, 8.7 magnitude young central star. The nebula is near a giant molecular cloud which contains the expansion of the bubble nebula while itself being excited by the hot central star, causing it to glow. Looks like the star is thought to have a mass of about 44, I don't know what that means. 44 giant large M. I'm not sure what that means. Is that 44 times the size of our sun? That's probably what it is. The hot star that's causing it has a size of about 44 times that of our sun. 44 solar masses, I think is what that large M stands for. Tweak it just a little bit more. Just see the bottom part is pretty faint, but the top part is very clear. Shock wave of that star pumping massive amounts of radiation out into a molecular cloud. Creates that shock wave. Looks like a bubble. Well, there's 10 minutes on that. Very cool. And there's M52. A bit blurry and out of focus way up there, but it's because the scope is back to being upside down again. But it got the bubble nebula nicely. So, that's pretty cool. Okay. So, now I think we are done with the easy targets. Now we get to the harder ones. ARP 273. Alright. ARP 273. Boing. Okay. Now we're going around to the east. Interacting galaxy, okay. So hopefully now we'll come back into focus. If not, we'll... manually refocus. Yeah, I think that's it right there. See if we can pick up these two little stars here. Yeah, see, there they are right there. A brighter one and a dimmer one. Wound around and out of orientation, of course, but because our Newtonian telescope flips and inverts the image, top to bottom and side to side. So things always end up looking a wee bit different. Oh yeah, we've got a couple little interacting galaxies. Small, we'll see what, yeah, that's why they're not the easy ones. Let's see what we can pick up from these. ARP 273. Let's see if Wikipedia even has something on these. They may be a bit obscure. ARP. Nope. Forgot the A. ARP 273. Ooh, looks like we might have an entry. There's a pair of interacting galaxies 300 million light years away. Well, it's a night of threes. Because the Triangulum galaxy, which we saw earlier on, is a little under 3 million light years away. Then we saw the Silver Sliver galaxy, which was 10 times further away at 30 million. And now we're going 10 times further away again at 300 million. So these are going to be some pretty small little dudes. And one of the reasons my color camera isn't ideal at doing galaxies is because it's not as sensitive as a mono camera, and galaxies mostly just transmit. They don't do a whole lot of color. They're mostly just gray anyway. But the other reason is because the pixels in my mono camera are significantly smaller, so they pick up a small detail better. So, but well, we can already see that they're the wispy arms of the bigger galaxy over here. Hopefully we'll be able to pick up the swirly shape, the swirly barred shape of the smaller one as we get more sub-exposures in. But we'll see what we can see. The larger of the spiral galaxies, known as UGC 1810, is about 5 times more massive than the smaller galaxy. It has a disk that is tidally distorted into a rose-like shape by the gravitational pull of the companion galaxy below it. The smaller galaxy shows distinct signs of active star formation in its nucleus, and it's thought that the smaller galaxy has actually passed through the larger one. Huh, that's interesting. The little guy actually collided with and went right through the other one, and it has warped the shapes of both of them in a pretty wacky way. But these are 300 million light years away, so that's pretty interesting. push that stretch a bit more now. Yeah, got a little adjustment we can make. Put you there. Squeeze you a little more. Get a little more brightness on this. Yeah. See how that looks when it comes across. Let's see if we can't zoom in a little more. There's two companion stars, which of course aren't companions. They're way closer in our own galaxy, but kind of neat that they're there. These stars here are in our galaxy. That bright spot, this bright spot here actually is the core of the galaxy itself. This is a star in our galaxy, and this is a star in our galaxy. If you look at the Hubble image of these, or one of the professional telescopes, you'll see the core will be the size, but these stars are much smaller. They're pinpoints. With my low resolution, small scope and low resolution camera, stars come out to be more blobby, especially when you're doing 60-second exposures. To make things brighter, stars do end up coming out, do saturate the pixels, so stars don't look like points too much. They can look a little bit like saucers, but especially the larger, brighter ones, like obviously this one. All stars are point sources of light, so the fact that they have any shape and size to them at all is simply because a 60-second exposure is oversaturating the brighter objects in the image, which in this case are the stars, just so we can have enough sensitivity to see the faint wispy stuff, which is the galaxies. So, but you can see now the shape of this twisty little wispy barred shape. You can see that right there. And then the swirly, and there's the core there, and this is all misshapen. This is pulled out and swirled much more to the bottom and right, because they think these are tidally locked, and the smaller one probably went through the other one, and they're in the process, their gravitational fields are in the process of pulling each other out of shape. This is all happening 300 million light years away, which means this all happened 300 million light years ago. 300 million years ago. And it's just taken this long for the light to get here. So but kind of interesting little objects there. I don't think we're going to spend much more time on them. I'll probably just move on. But interesting little objects nonetheless. Okay, M74. Well, this one should be bigger and brighter. M74. Doink. Okay, well, back around to a little bit of the more southern sky. The Phantom Galaxy. Okay, yeah, there it is. Right there, big as day. And this is looking pretty unfocused, so I'm going to just find a nearby bright star. Hey, conveniently, there's one right there. Do a quick focus. Be right back. Okay. Managed to hit it quick. Alright, back to M74. Another nice spiral galaxy, M74. Okay. Yeah, I think that'll work. Yeah, dead on. Well, let's see what we can pull in for the Phantom Galaxy. Okay. M74. Alright. Messier 74 is a large spiral galaxy in Pisces. It's about 32 million light years away from Earth, so again about the same distance as the Silver Sliver galaxy we looked at earlier. Except this one we're going to be looking at pretty much face on instead of edge on. So, a different kind of spectacular image. Galaxy contains two clearly defined spiral arms and is therefore used as an archetypal example of a grand design spiral galaxy. And I'm seeing stars that are kind of elongated and streaked a little bit. So I think I am going to reset this because the mount was obviously not quite fully set when I started the first sub. So we're gonna, yeah, it's all kind of blurry. So we'll definitely reset this. Clear and start again. Get stars that are not streaky or Easter eggs. The galaxy's low surface brightness makes it the most difficult Messier object for amateur astronomers to observe. Its relatively large angular size. Wow. Streaky stars again. Well, one last time. If this doesn't work, then I guess it's just there's something up with this specific position. And my mount for some reason. Its relatively large angular size and the galaxy's face-on orientation make it an ideal object for professional astronomers who want to study spiral arm structure and spiral density waves. It's estimated that M74 hosts about 100 billion stars, so about a quarter of the stars of our own Milky Way. Size. There we go. It just took a couple of minutes for the mount to settle. But yeah, now we have round stars, and already you see a lot more detail in the galaxy than you could before. So now we should actually get a good image. Michael, what's causing my focus to go out? Yes, it's a actually, it's a number of things. Temperature is always something. But that's not really what the extent of what's happening here. Over the course of an observing session, I sometimes need to change focus once, maybe twice. The reason I'm having to do it so much tonight is because my because I am on an AltAz mount with a wedge, like this. When the mount is obviously polar aligned with the north sky. Whenever I want to see something in the northern sky, the scope actually flips upside down. So instead of the focuser being pointed up, it's actually pointed down. And this is not the highest cost focuser or telescope, so there is a slight amount of focuser flop that happens when this thing points more to the northern sky. And so that's a big part of what I'm dealing with tonight is Roll tends to like things in the northern sky. I don't know if he just that's where his hole in the trees is or whatever, or just pointing away from neighbors' lights, but he tends to like to, if last month's and this month's targets are any indication, he tends to like things that are fairly near the northern sky. And so for my particular setup, that's a pretty big challenge because the scope does flip upside down. So that's the primary thing that's knocking my focus out, depending on where the object is. But yeah, over the course of an evening, especially a winter evening like this, where the temperatures will drop, just clear, cold air, which is pretty warm in the daytime, cools off really quite a bit at night. We will have typically a 40 to 50 degree Fahrenheit temperature drop from daytime high to overnight low. Right now our daytime highs are in the low to mid 70s and our lows are in the mid to upper 30s. I think it's going to get down to 35 tonight. So you're looking at pretty close to a 40 degree temperature differential, Fahrenheit obviously, 40 degree temperature differential between day and night. So the temperature will drop over the course of a 2 or 3 hour observing session. It will drop pretty well. So I am definitely bundled up. I'm in my winter gear and managing to stay comfortable, but yeah, the temperature is dropping here. So some nice structure in this. There's one spiral arm, and there's 2 spiral arms. And lots of wispies coming off both of them. Much fainter, wispier arms spinning off those primary arms, but you can see these areas here, these fuzzy, bright patches that are not. These are stars in our galaxy, so these are all foreground stars. These bright, sharp white things, but the bluer, fuzzier ones are all high-energy regions of this galaxy that are probably have a lot of star formation going on or other high-energy activity. And so that's kind of cool to see all that there. Yeah, mid-20s at night. Yep. Winter, that winter air, it's dry and more stable, which makes for great astronomy. Winter air is definitely more stable and drier than summer air, where there's a lot more thermal activity happening. There's a lot more humidity in the air, but it's cold, so as an astronomer you're kind of stuck in the cold, but that's what we do, right? We come out here in the cold and sit in the cold, although one thing that EAA allows you to do is you can actually network your computer and leave the computer and the scope and mount and everything outside and network the two computers and actually remotely control the outside computer with an inside computer and be sitting at your warm desk chair doing all of this instead of sitting out in the cold. And I can do that too. I have done that in the past. I was doing that for a little while and it works great. The problem is when you then also throw in the bandwidth of live streaming on top of that, then it got too much for my network. My home network can handle either the live stream bandwidth so that I can broadcast this to you, or I can control it remotely in the warm comfort of my house, but not both. So here I sit being a real, quote-unquote, real astronomer out next to the scope in the cold, so I can broadcast this stuff to you. But, you know, like I said, we're only getting down into the mid-30s here, so can't complain too much. You know, and those temperatures really only you see those in the early morning. Most of the time out here I'm probably about 50 degrees, maybe low 50s. Which doesn't sound very cold until you sit still in it for an hour or two. Worst part about us is this is just such a sedentary thing that there's no opportunity for you to really warm up. And you can see my stars here have gone back to Easter eggs again. So I've got a blurry sub-exposure that was just added, and it kind of blurred the galaxy itself. So, oh well. This is where, you know, the inaccuracy of my inexpensive mount shows up. Now I do have an FWHM filter, which basically has a blurry. Now if you get blurry, it rejects them, but yeah, you can see these are actually really good numbers. But if I were to drop it to 6, now anytime it gets even a slightly blurry one, it'll reject those. But that won't necessarily get rid of what I want, so I don't know. Slightly streaky is not necessarily going to give you an FWHM number that's got to be rejected, so anyway, trials and tribulations. These are first world problems. See a small faint galaxy to the lower right. Yeah, looks like there's a little puff down here. Yeah, there's often galaxies. You see, here's another down here, which looks like an elliptical down here. There's often many galaxies in our view. Here's one over here, looks like. So anyway, a nice little galaxy, nice little structure to this, but we got a blurry sub in there, so I think that's just means it's time to move on. What do we got next? Roll, okay, 1275, and GC 1275, boink, okay. See, back up to the northern sky again, so here the scope is going to flop back over again. So I may skip it. Let's see what 1501 does. Even worser. Yeah, Roll likes the northern sky, which is tough for my little scope. Well, let's go back to 1275. It wasn't so bad. It's almost east facing. So let's try 1275. And do this little active galaxy that's in here. See, you can tell how out of focus it is. It's already pretty blurry. It looks a little blurry. What have you got here? Roll that isn't in the northern sky, so I have to get, well, 15, 14. GC 15. Oop, come on. NGC 15, 14. Crystal Ball Nebula. Oh, another planetary. Let's go over that one. Yeah, that one will be better for us. Oh yeah, little planetary there. Alright, yeah, see the scope. Let's pull it back into the center, which should help it. Okay, which should help it stabilize a little. Let's see what we can pick up of this planetary. Looks like a pretty faint one, so we'll try a 60-second. Usually with planetary, 60-second exposures are a little too much, but yeah, got a little bit of a shape there. Pretty small though. We'll see what we can pick out. Again, probably would have been a better target for the mono, for the 183 mono, but we'll see what we can pick out. I've often thought of increasing my focal length by going to an 8-inch imaging unit instead of a 6, but it would really push the mount to its weight limit, so I'm not sure how well it would work. Oh yeah, look at that. That's pretty blue. Look at that. Oh, that actually came out a lot better than I thought. Alright, let's see if we adjust things accordingly. Drop a little blue out of it. Yeah, actually it came out pretty nice at 60 seconds. So that's a pretty dim planetary nebula. Yeah, the 290s are nice for galaxies. They're pretty darn sensitive. They have small pixels, but they're pretty darn sensitive. And so that makes them really good for galaxies. They because the small pixels help you bring out that small detail that the faint small galaxies have. Well, even the close-up galaxies, you're picking out details in all the individual arms, which is kind of nice. So the small pixels are pretty nice, but even for a small pixeled camera, it's pretty sensitive. So the 290s are nice. The one, of course, drawback to the 290 is that it is a 1/3 inch sensor. So it's a very small sensor, so your field of view is really small. What kind of scope, what kind of focal length are you going to be using that 290 with? Hopefully not too big. I forget what scopes you have, but yeah, that's the biggest drawback to them, is that they're just really small field of view. I wish they'd come out with a bigger version of that sensor, but oh well. That just continues to be my wish. Yeah, this came out pretty nice, actually. All looks good. Oh yeah, an 8-inch cat. Yeah, so that's 2,000 millimeters of focal length at f10, and you're probably using a, what, an f6.3 an f6.3 reducer with that, so you're still at almost 1,400 millimeters of focal length. So that's going to be a very, very small little field of view. So that'll make it challenging to find targets, but you know, with plate solving, well, even plate solving is tough at that small a field of view. But you know, it makes it harder to find targets, but once you get on it, you'll probably get some really nice detail on those smaller galaxies. Yeah, but this is showing some nice nice detail. Zoom in even a little more. Try not to zoom in too far because it just gets grainy, but actually I think roll. Oh yeah, the double reducer. Two stacked 6.3s. Roll actually is, that's exactly what he has. He has an 8-inch cat, and he does the same thing. In fact, I think the 290 is what he's using. Well, let's go look. Evo 8, which is the same thing as yours. 533. He uses it at f5. Okay, so he uses the 290 with his 6 SE. So the 6 only has 1500 millimeters of focal length. Cut in half at f5 is 750. So he's only running 750 millimeters of focal length with his 290. And he's running 1000 millimeters with the 533. So no darks or flats. Let's see. Here's the 290. You know, the cocoon that we looked at earlier. So that's it. It almost fills the whole view of his 290 at 750 millimeters. You would see about half this with your C8 and the 6.3 reducer. But if you stack double 6.3s, well then you're getting down to about f4, which is about what I'm running. So, oh yeah, it could have been a triple plus or Errol. Yeah, he let's see what he runs, because I'm pretty sure he was one of the first people to respond. Oh, still roll, still roll, still roll. Okay, well there he is, but he is not saying what he's... I'm not sure that he's actually contributed to... there's Pat. Yeah, I'm not sure what he's using, but you could be right. I think Errol does have does use that setup. Well, anyway, hey, and there you are. Yeah, I think you're right. I think he does. I think Errol may run that setup as well. Let's go back to our image here. This is coming out pretty nice. Oh, I got 2 ignored. Yeah, that's because I turned the FWHM filter up. I should probably just turn that back. Yeah, because they were just barely out. The reality is they're not really going to reject. They're not. These really aren't going to make that much of a difference. So, rejecting them isn't going to do a whole lot for us. Shift-click this and get this in there. Let's push that stretch a little bit more. always get it a little bit brighter. Yeah, for me, I haven't been out to do my last live stream was, I think it was Halloween. I think it was the 28th of October was my last live stream, and the one before that was in June, I think. So between the weather and my schedule and just life, I have not been out doing many live streams at all. So nice to get out tonight to do one. And this will probably be my last one of this Dark of the Moon, since last night was the new moon. And I don't think I'll be able to get out in the next night or two. So probably going to be the end of December before I get out to do any more. And that's the holidays, and I have no idea what's going to go on there. So don't know when I will be doing my next one, but it will probably be maybe even early next year before I'm back out. Yeah, the 294 is nice for longer focal length, because it's got those big pixels, so it's pretty nice. It's pretty nice for long focal length scopes. They eat that up. Yeah, Corey actually was Corey was kind of an inspiration for me. He was doing these before I was, and so he was an inspiration to me. Him and Gary Hawkins, who unfortunately is no longer a member on the forums because he ran into some terms of service issues and, well, politics. But both Corey's and Gary's were both instrumental in inspiring me and teaching me how to do it. So especially Gary. Gary taught me a lot. I asked him a lot of questions, and he taught me a lot about how to do it. So that was a cool thing. But yeah, Corey's done some really nice stuff. He's on the East Coast as well. He's in Massatucky, and so he runs into the same, New England weather, East Coast weather, a lot more humidity back there that you guys deal with, a lot more clouds. So the challenges of living on the right coast. But and so he hasn't been doing them very much at all lately, which is too bad because I like his streams. But yeah, he definitely does some nice streams. He also uses a 294, but he uses an 8-inch imaging newt, so he's using that with about 800 millimeters of focal length. So he could actually use a little more focal length for that camera, but he does some good stuff. Anyway, so there is the Crystal Ball Nebula, or the Pansy Nebula. That came out actually pretty darn nice. I like that. That came out pretty well. Alright, let's see what's next. Shoot, I've forgotten where I am. That was 1514, right. Because I skipped these because they're really far into the north sky. Let's see what's 7129. F3 NGC 7129. Yeah, back to the northern sky. Small cluster nebula. Yeah, back to upside down again. Wow. Yeah. Well, actually it's it's twisting around so much that it might actually work. Yeah, let's give that a try. Okay, small cluster nebula. Ooh, it looks very much out of focus. Yeah, That's way out of focus. It's right there, though. I think what I might do, since I'm coming up on 2 hours and starting to get a little chilly, I think I will refocus and we'll do this one and call it a night. Constellation lines are out. Right in the middle of Cepheus. Okay. Let's go do a refocus on this and we'll pull this one in and call it a night. I think that's what it'll do. Alright. Alright, I'll go focus and be right back. Alright, let's see if we can pull this sucker in. Alright, let's hope our focus holds. And the northern sky is tough for a wedge-mounted AltAz mount, and unfortunately, it seems to be the direction that Roll loves, so bit of a challenge. Alright, guess we get close here. Yeah, well, not terrible. I could have centered it a little bit better, but yeah, in fact, I want to do that. I want to recenter this. We're going to take the time to get it. Might as well get it right. Let's recenter this. And bring it up a little bit. Send it over. Come on, you can do it. Go over there. There we go. Now we'll bring it back a little so that the backlash stops. And that should be pretty stable. Alright, that should come out a bit sharper than what we were looking at. Means we have to do another 60-second wait for the first image, but I think it'll be worth it to get this. Okay, and this is... Well, this was 7129. Let's see what we have to say about 7129. NGC 7129. Boom. It's a reflection nebula located 3,300 light-years away in Cepheus. A young open cluster is responsible for illuminating the surrounding nebula. Huh. So it's a star-forming region with a bunch of young stars. A recent survey indicates the cluster contains more than 130 stars less than 1,000,000 years old. Those are pretty young stars. It's located just half a degree from the nearby cluster of 7142. Yeah, there's a nice... That's a nice cluster. GC 7142. Doink, 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 doink. Nice cluster of stars there. Yeah, this is coming out much better now that we've got it in the center. Much better now that we got it in the center. So this should pull in a nice deal. The nebula is rosebud shaped. The young stars have blown a large, oddly shaped bubble in the molecular cloud that once surrounded them at their birth. The rosy pink color comes from glowing dust. We're not getting much of the rosy color yet. Let's make sure our color balance is right. Give it a little boost. Okay. The color comes from the glowing dust grains on the surface of the bubble being heated by the intense light from the young stars within. The ultraviolet and visible light produced by the young stars is absorbed by the surrounding dust. They are heated by this process and release the energy at longer infrared wavelengths as photographed by the Spitzer Space Telescope. The reddish colors in the false color infrared image suggest the distribution of hydrocarbon-rich molecular material. The young stars near the center of the nebula are sending jets of supersonic gas into the cloud. The collision of these jets heats carbon monoxide molecules in the nebula. This produces the complex nebulosity that appears like a stem of a rosebud. Okay, right, which is the bottom part. Which is actually down here, because we're, again, the Newtonian telescope inverts the image. So I'm not sure. With the color camera, might not get that much detail, but we'll see what we can get. And the scope is, of course, upside down and sideways, so it's a little wacky anyhow. It actually also throws my flat off, my flat frame, because when the focuser flops slightly, you get enough of a change that the flat frame could actually be altered as well and not work quite as well. But we'll see what we can pull in here over the next few minutes. Hey, Doug. Glad to see you made it. Yes, can't have too many mics on a live stream. Definitely cannot. Not sure how much detail I'm going to be able to pull out of this, but we'll see what we can see. We've got a nice shot of the cluster down here, though. So close to it. getting them both together. Yeah, sorry that I didn't make the December group live stream there, the EAA event, but 2 a.m. Pacific time was a little bit more of a challenge than I was up for last night, so I did not want to make that one. Unfortunately, the Australia time zones are right in the middle of the night for us, so but I really love that you're doing those, and really try to make them whenever I can. So thanks again for hosting them, and I haven't watched the video of last night's, but I'm sure it was a good one. How many people did you end up having on? Sounds like there was a few people from down under that were on last night. Seven? Wow, impressive. Nice. It's very cool you got that many to come on. Seven or so Aussies and one Yank. But yes, they definitely need to have their day in the sun. It's just unfortunate that they're so chronologically opposed to, well, certainly here in the States. I guess Europe it was mid-morning-ish, I guess. It's 5 a.m. East Coast, which isn't terrible. Actually, I was up at 5 a.m. this morning, so if it had gone that long, I'd have been able to chime in late, but I guess it was late morning in Europe, so that's not too bad for the Euros to be able to attend. Oh, that's right, Phil got on from Europe, yeah, so that's why he was at, I think, 10 a.m. So, yeah, which is Noah 4x4's real name. His name is Phil, actually. But, yeah, so he was on. I forgot about that. Actually, would have liked to have met him. I've never actually done a face-to-face with him. We've certainly exchanged a number of posts. He's a fairly prolific and helpful poster on cloudy nights, but have yet to do the face-to-face. More I'm going to pull out of this. Let's see what we got left. So we did 7129 is what we're doing now. These three, 1275, 1501, and 1514, turn my scope upside down. UGC 12914. UGC 12914. Let's see. Where are we with this? Actually, fairly southern sky. Alright. These are very faint, small galaxies. So I don't know that my scope is going to be able to do much of these. But that's a possibility. I don't know that I'm going to be able to do much more of this. I also don't get really hardly any of the red color. To me, it mostly looks like bluish. But I guess maybe you need to have the hydrogen beta filters to really see the red. But I don't get any of the red in here. But that's because I'm running without filters. If I had a hydrogen beta filter on here, I'd probably get a lot of the red. It's like the Horsehead Nebula. Although actually the Horsehead Nebula comes out as nice and red in my view. So Taffy galaxies. Yeah, I don't know that I'm going to be able to see these, but let's swing over there and see what happens. Back to the southern sky, which hopefully will bring the scope into better focus from flopping back and forth. Yeah, I can see them right here. Well, let's pull a sub, see what happens. It's possible we might be able to see something. Unfortunately, Stellarium doesn't have an image of them, so I can't tell how big they are, but they're probably not big. Well, size, yeah, we're almost 2 arc minutes, so that's not too bad. I might be able to pick something up out of this. We'll see what we have to see what we Oh, you want to see a rich star field? We did earlier. One of the easy objects that Roll picked out was the Cocoon Nebula, which is right in the arm of the Milky Way. Talk about a rich star field. That's just a crazy rich star field. All right, we're gonna need to brighten things up a little bit here. But yeah, you can see them in here. A little pair of interacting galaxies. Which right now, I'm going to back off on this a little bit because too grainy. But you can see them in here, and as we pull in some more subs, how are things going with the Rasa, Doug? Are you did you figure out the mount issues? And I guess now you're having Stellarium issues or something, because Stellarium froze up on you a couple times. But how's the mount and scope working? You got it figured out? I should have nuked that first frame. I've got some Easter egg stars here. Well, I think we're going to call it good enough. Because I'm getting cold. I've been out here for 2.5 hours, so. Yeah, you can see them in here though, but I think I'm going to reset this. Because the mount looked like it was not quite settled when I got these. So I'm going to clear this and start again. See if we can get actual round stars and not streaked stars. Yeah, that's a little bit better. Yeah, it's a little bit better. Not perfect still, but we'll let this run for a few minutes, see what that does. Oh good, you got the mount figured out. I forget what the heck problem you were having with it, but you could not, it seemed to me you couldn't even communicate with it or something. So, that was your last frustration. Windows 11 must have ruffled your ASCOM. Okay. Okay, so you just need to uninstall and reinstall. Yeah. I updated this computer before coming out today, and as I always do, and it gave me the message, you can upgrade to Windows 11 now, your PC is compatible and you can do it now, go ahead. And no thank you. I will let other people like you, Doug, beta test Windows 11 for me and figure out all the bugs so that I can get a nice stable version, you know, in a year or two when I'm ready to actually upgrade. Yeah, yes, I don't need to have snow here. That's one thing I don't miss is snow. I actually was born and raised in northern New England in New Hampshire, so I definitely spent my time around snow, and don't really miss it all that much. So we still get cold here, and the flakes will fly here every once in a while, but it's pretty rare for them to stick. So yeah, these two little guys are actually kind of small for my camera. At 600 millimeters of focal length, my 533 is not doesn't do well in real small stuff. Stuff like this I prefer to use my 183 mono on. It's more sensitive, and the much smaller pixels do a better job picking out the fine details of little targets like this. But, well, you can see that they're there. They're just not really well defined. Yeah, it is dry. It is dry here. You gotta drink plenty of water. You can get dehydrated, but yeah, the dry air is definitely nice. It's more stable. Your transparency is better, so you get better contrast for both visual and imaging. So it's definitely nice. I am not complaining. I'm just glad that I have good enough internet that I can actually broadcast this. You know, bring these great images to the rest of the world who doesn't necessarily want to live in a desert that hits 120 plus degrees in July. They don't want to deal with living out in the middle of nowhere. So, but I kind of like it. Thank you, Doug. I really like my diffraction spikes. I have a refractor snob friend who we give each other crap all the time whenever we're on a live stream together. We're both members of the Las Vegas Astronomical Society, and during COVID, when they had to have their actual in-person star parties shut down, we were doing a monthly live stream instead. And so, you know, we would basically, all of us would get on a Zoom and we'd share time and go from one scope to the next scope to the next scope, see who had an image up. And you know, I would always absolutely celebrate my diffraction spikes, and he'd just roll his eyes. So it was fun going back and forth with Greg. I miss doing those. We had a good time. It was some good astronomy, but mostly it was the camaraderie that that was enjoyable, because we had a good time together. It's probably as entertaining to listen to as it was to watch. The Middle East in 130 degrees. Yeah, but I think well, yes. 130 degrees is nasty. I don't care what it is, but I think there's also, Middle East also has a fair amount of humidity to go with that 130 degrees too, which is just really miserable. We only hit really high temperatures when it's pretty darn dry. So when we have our monsoonal stuff, it cools off a little bit, but then it gets muggy. And 105 with muggy is, quite frankly, a lot worse than 120 and dry. I'll take 120 and dry anytime. I'm not sure we're going to pull out a whole lot more out of these. Let's see what, if there's anything that really rocks my boat. But I think I'm probably about done. Whoa. What the heck? NGC 2069 is well below the horizon. Okay. Yeah, I don't think we're going to be doing NGC 2069. Oh, actually, somebody further down said there was a typo, and I think he meant NGC 206. Which, actually, if I recall correctly, What? What just happened? Something did not happen right. NGC 206. U, which I believe is in Andromeda. Yeah, so it's part of the end. Yeah, this would be a great way to finish up. Obviously Andromeda is, because we've been talking about Andromeda all night. So, let's see. Yeah, actually, maybe it'll... Let's... Okay. So there's Andromeda up there. And there's the great star cloud in Andromeda. So I'm actually going to cheat a little and pull Andromeda down into the image just a little bit. Whoop, that's the wrong button. You need to do the other button to actually pull. So there's Andromeda right there. And I'm just going to leave it right there, I think. Now, the interesting challenge with this is the core of Andromeda is really bright. But the wispy outer parts of Andromeda's arms are not. So I'm going to stick with 60 seconds, and we'll just have to play with the histogram to get different parts of it to come out. We'll have to back way off on it to see the core without it being blown out. And we'll have to get more aggressive with it to bring in NGC 206. Which is a star cloud that's in the Andromeda galaxy. So, but this is a good way to finish up, especially for my camera, which is better on bigger, brighter, shinier objects anyways. So and when we drew stars as kids, they always had spikes. Yes, they did. That's how you knew it was a star. Whee! Well, there's the big, bright, beautiful Andromeda galaxy. Which is, as we learned earlier, more than double the stars of the Milky Way. The Milky Way having approximately 400 billion stars. Andromeda has about 1 trillion stars. So by far the biggest member of our galaxy, of our local cluster of galaxies. Triangulum had 40, we have 400, and Andromeda has 1,000 million stars. And of those stars, we have this the great star cloud of Andromeda, which has its own new general catalog number, NGC 206. It's such a significant object. There aren't many objects in other galaxies that have their own NGC numbers, but this is one of them. There is the great star cloud there. And all the globs that are in M32. That's nice. I must be running something with 1100 millimeter focal length. Nope, I'm just running 600 millimeters. Oh, I'm sorry, you're talking to the other mic. Yeah, see, we need to distinguish Mike from Mike, because I don't know who you're talking about. Right, you meant other Mike, not me Mike. Mike K. Actually, my best friend growing up, his name was Mike K. In grade school. I was Mike J, he was Mike K. Yeah, the dust lanes come out nice. 533 does a really wonderful job, actually. I just need more focal length to get some more detail on the smaller objects. But Yeah, in fact, we're getting that right there, which is M32. So we're going to get, the whole thing, of course, is sideways, but we're getting M32 there nicely. We're not quite getting 101. 101 is here, which means it would be up here, just above the frame. We're not quite getting M101, which is this other companion galaxy to Andromeda here. But we're getting 32. Nice elliptical galaxy right there. It's not a star, that's an actual, it's a satellite galaxy of Andromeda. And right here, this puff of light right here, is our desired challenge target. It's NGC 206, the great star cloud of Andromeda. Let's see how we're doing here. Pretty good. Got a lot of light. Got a big gradual drop-off curve there. We got a lot of light in this. Such a bright galaxy. Nice way to finish. Now, I'm also noticing that I need to kick this up a bit. Whoops, that might be too much. Because you guys are not seeing the brightness I'm seeing. Gotta remember to kick it up, because otherwise you guys can't see. Yeah, that really brings out the star cluster even more. That bright blue spot, nice blue glow in it against the core of Andromeda. Can I zoom into 206? Sure. Again, it gets blurry when I get in there because this camera doesn't have the best resolution, but you can see it's definitely a bluish color compared to the whitish yellow of the rest of Andromeda. Yeah, that would be pretty cool to think there's somebody there looking at us. Well, you know, there's 2.5 times the stars there that there are here. So there's got to be some, I mean, there's got to be other life here. There's got to be other life there. It would be inconceivable to think that we would be the only life. Absolutely inconceivable. Yep, statistically speaking, it's virtually impossible that we would be alone. Oh, I don't know. Cinder block pier, that's, I don't know. That's a pretty high level of tech. They'd have to be pretty advanced to have the cinder block pier, especially with the included storage holes. I mean, pier and storage? Come on. That's some specialized stuff there. That is some pretty advanced stuff. I would not expect that to be universal. But, hey, that's just me. Well, gents, I think I am going to call it a night. I'm getting cold and hungry, and I think it's time to head in. So I think I'm going to do that. But thank you for joining. It was a lot of fun. And thanks for showing up late, Doug. Thanks, Mike, for being chatty. It's always nice to have people who want to chat, rather than just me sitting here yammering at nothing. So, thanks for being chatty, Mike. Thanks for coming, Doug. And, yeah, I will, probably won't see you for a little bit, but maybe after the first of the year, perhaps. We'll come back out here again and do something else. You know, I did the November challenge in December. Maybe I'll do the December challenge in January. Who knows? But yes, good night, folks. Thanks for joining, and I will see you next time. Good night, everybody.